Alright guys, so we want to talk about the fundamental theorem of calculus. Sounds pretty scary, but we've actually been doing this already. Okay, so I've already set up a little diagram here to save some time, and it's very similar to what we've looked at already. So here we've got some function. Now I'm going to use some words that I haven't before. So we've set it up as this function called f of x, but we're going to talk about this as a continuous function. And for the reason for that is when we're talking about the fundamental theorem of calculus, one of the key criteria is that it is a continuous function. What that means is that it doesn't stop here. So it's not as though it's valid for all values except x equal to like 2, right? So there's no conditions on the fact that there aren't any values for which it doesn't exist. Okay, so it's continuous in that regard. So that's an aside. So we have this continuous function, and we know that for this function that the antiderivative exists. Okay, so the antiderivative is equal to f capital of x. Okay, so we're making the assumption that that exists. And if that does exist, then we talk about it as the integral, using this integrand symbol, between a and b, which is literally just the bounding values that we give it, of f of x with respect to x dx is given by capital F between b subtract capital F between a. Okay, so this is, we have seen this already, but I suppose we're just putting a name to this. This is called the fundamental theorem of calculus. And really all it's saying is that, that the area that lies underneath this curve, bounded by the x value, and the vertical lines that these, the x value of a and x value of b make, right? So this area in here bounded by here, the area that's bounded by a and b, that function, and the x axes, is given by the antiderivative when b is substituted in, subtract the antiderivative when a is substituted in. And really, remember what this means. The antiderivative of b, or f with antiderivative with b substituted, is really just this whole area that's bounded from 0 up to b. And then I'm subtracting this area, which is the whole area that's up until a. So it's really just a substitution of areas. And that's it. That is the fundamental theorem of calculus. So it sounds like something scary and complicated. It's really pretty straightforward in terms of what we've already done.